Hello friends, today we will start lesson number 1 from maths, real numbers. So in this lesson we will cover following points. First, what is meant by real number? Already all of you are aware of all types of numbers. We will revise it again. Then we will learn what is composite number, what is prime number, and then we will go for fundamental theorem of arithmetic. Then how to find LCM and HCF by factorization, prime factorization method. Then next point is relation between LCM, HCF and given 2 points. And lastly, we will see how to prove the irrational number. So here we will have the revision about types of numbers. So you know, first is natural numbers. What are natural numbers? Those are counting numbers, 1, 2, 3 and infinite. Then whole numbers, only add 0, 1, 2, 3, 4 and so on. Then integers, dot, here infinite, -3, -2, -1, 0, 1, 2, 3 and so on. Then rational numbers. Rational numbers, the number which can be expressed as P upon Q, where P and Q are any integers. But the condition is very important condition, Q should not be equals to 0. So such type of numbers are rational numbers, and the fifth one is irrational. And all these 5 types of number together called real numbers. So all these numbers can be shown on the number line. Those numbers are exist and those numbers can be represented on the number line. That's why these numbers are called real numbers. Then what is meant by composite number and prime number? Very important. Composite number is a number having divisors, one the number itself and some other divisors. But prime number is a number which has divisor one and the number itself. For example, we can see, if we can take 4, so it can be expressed as 2 into 2, or the prime factors of 4 are 1, 2 and 4 itself. So this is composite. So 4 is composite. If you take 11, 11 has factors 1 and 11 only, and that's why this is prime number. So you must know what is composite number and what is prime number. This is very important for this lesson. Then we will see fundamental theorem of arithmetic. So this is very important. We will see how to find LCM and HCF by prime factorization method, then relation between LCM, HCF and given 2 numbers, and how to prove the irrational number. So this is the content of this lesson. So let us see what is fundamental theorem. This is the first point which we have to study in 10th standard. So what is the fundamental theorem of arithmetic? Fundamental theorem says that any composite number can be expressed in its primes. For example, let us see any composite number. We can say, suppose 81. So 81 can be expressed. The prime factors, we can use two methods, either tree diagram or ladder method. So ladder method is very much convenient. So let us take 81. Find the factors. So there is 1 at the unit place, so it will not be divisible by 2. 8 and 1, 9, so it is definitely divisible by 3. So take 3, 3 to the 6, 2 carry 21, 3 7s are 21. Now 3 9s are 27, and 3 3s are 9, and 3 1s are 3. So 81 can be expressed as 3 into 3 into 3 into 3. So 81 is a composite number. It is expressed in terms of its prime factors. So if we write in terms of power, so 3 raised to 4. So 81 can be written as 3 raised to 4. One more number if you take, suppose take 20, factors of 20 can be written as 2 into 2 into 5. So 2 raised to 2 into 5. So in this way we can find the prime factors of any composite number. So that is the fundamental theorem of arithmetic. Any composite number can be expressed in terms of its prime factors. These numbers or these factors can be altered. So order is not important. You can write like this: 5 into 2 into 2, or 2 into 5 into 2. So order is not important, but the factors, those factors are unique. So that is fundamental theorem of arithmetic. So we will write the statement for fundamental theorem. Fundamental theorem of arithmetic. So any composite number can be expressed in its prime factors, which are unique. Here order of prime factors is not important. So this is how we can write the fundamental theorem of arithmetic. Now by using this theorem, by using prime factorization method, we can find out LCM and HCF. If you take any two numbers, suppose if you take two numbers, and we will find prime factors and then LCM and HCF. So 96 and 404, so which 96 is a composite and 404 is a composite. Let us take example. More examples will be solved in exercise 1.1. So first find the factors of 96. It has 6 at unit place, so we can divide it by 2. 2 4 is 8, 1 carry 16, 2 8 is 16. Again 2 2 is 4, 2 4 is 8. Again 2 1 is 2, 2 is 4. Again 2 6 is 12. 2 3 is 6 and 3 1 is 3. 404. Find the factors. 2 2 is 4, 0, 2 2 is 4. 2 1 is 0, 1 is. Now see this 101. I can write 101 as Now 96 is equals to 2, 1, 2, 3, 4, 5. 2 raised to 5 into 3. 404 is equals to 2 into 2 into 101. Now, so these are the prime factors of 96 and 404. Now, by using these prime factors, we can find out LCM and HCF. So, what is LCM? What is HCF? We will see. So, LCM is the product of all factors with highest degree, and what is HCF? All common factors, product of all common factors with least power. Once again, what is LCM? LCM is the product of all factors in those numbers, not common, all factors of those numbers with highest power. And what is HCF? Product of common factors with least power, that is LCM and HCF. Then what is the relation between LCM and HCF? If LCM of A comma B, A and B are any two composite numbers or any two numbers is given, and HCF of same two numbers is given, then we can write LCM into HCF is equals to product of given two numbers. So this is the relation between LCM, HCF and given two numbers. This is applicable when only two numbers are given. That is, it is not applicable when you are finding the LCM and HCF of three numbers, then this relation is not applicable. And the last thing is how to prove the irrational number. So examples of irrational number are root 3 is irrational number, root 5 is irrational number, root 7 is irrational number, 2 plus root 5 is irrational number, root 5 upon 2 is irrational number, 2 root 7 is irrational number. So such type of numbers are irrational number, but in standard 10 we need to prove how these numbers are irrational numbers. So here ends this lessons points to be learned in this lesson. Now we will start first exercise 1.1. So exercise 1.1. So you can open the books now. I will not write the full question, I will only start answers. So let us start exercise number 1.1. Exercise 1.1. Question number 1. What is the question? You can open the books. Express each number as a product of its prime factors. So first sub question 1, 140. So you can find by either way, ladder method or tree diagram or tree method. I will explain first example with both the methods. So 140, this is ladder method. 2 7 is 14, 0, 2 3 is 6, 2 5 is now unit place there is 5, so it can be divisible by 5. 5 7 is 35 and 7 1 is. So we can write 140 is equals to 2 into 2 into 5 into 7, but it can be written in terms of power 2 raised to 2 into 5 into 7, or this can be solved by tree method. So this is 140. So the first prime factor is 2. Here it will be 70. So otherwise you can write 2 into 70. Now this 70 can be splitted as 2 into 35. Again this can be 5 into 7, and now this 2 into 2 into 5 into 7. So 140 can be written as 2 raised to 2 into 5 into 7. So you can solve it either way, but this is most convenient method. Second example, 156, sub question 2. 156, we will use ladder method. 156, it is divisible by 2. 2 7s are 14, 2 8s are 16, 2 3s are 6, 2 9s are. Now it is divisible by 3. 3 1s are 3 3s are, 13 is a prime number. So 13 1s are 13. Therefore 156 is equals to 2 raised to 2 into 3 into 13. Example number 3. 3825. 3825. So 3825, definitely it is divisible by 5. So 5 7s are 35, 3 5 6 the 30, 5 5s are 25. Again 5 1s are 2, 5 5s are 25, 5 3s are 153. Now it is divisible by 3. 3 5s are 15, 3 1s are. Again 3 1s are 3 7s are, and 17 is a prime. So 17 1s are. So 3825 can be written as 3 into 3 into 5 into 5 into 17. Order is not important. So 3825 is equals to 3 raised to 2 into 5 raised to 2 into 17. So these are the prime factors of 3825. Now sub question number 4. Sub question number 4. 5005. 5005, it is divisible by 5. 5 1s are 0 0, 5 1s are. Now it is divisible by, it will not be divisible by 3, it will not be divisible by 2 3 5 7. We will try with the 7. So if it is divisible by 7, we will divide it. 7 1s are 7, 3 0 30, 7 4s are 28, 2 1 7 3s are 21. 143. Now it is divisible by 11, 11 ones are 11, 11 threes are 33, and now it is divisible by 13. So 5 0 0 5 can be written as 5 into 7 into 11 into 13. Sub question number 5. So this is slightly hard. 7429. 7429. So let us see the test of 3. All the sum of all digits, 7 and 4, 11, 12, 13, 13 and 9, 22. So it is not divisible by 3. So it is directly divisible by 17. 17 for the 68. 6. 17 3 is a 51, and 17 sevens are 119. So 7s are. Now it is divisible by 19. 19 to the 38, 5, 19 3 is a 57, and now 23 is prime, so 23 ones are 23. So it can be written as 7429 is equals to 17 into 19 into 23. So these are the prime factors. So this ends question number 1. So now we will go for question number 2. Question number 2. Find the LCM and HCF of the following pairs of integers and verify LCM into HCF is equals to product of two numbers. So first is 26 and 91. So first find the prime factors by ladder method. 26, 2 ones are 2 threes are 13, 13 ones are, and 91 can be so this can be written as 26 is equals to 2 into 13, and 91 is equals to 7 into 13. So LCM is take all factors 2 yes, 7 yes, and 13. All factors 2, 7 and 13, and the product of all these factors is nothing but LCM. 2 into 91, so it is 2 ones are 2. So LCM is equals to 182, and now HCF is all common factors with least power. So common factor is only 13, so 13 is the HCF. Now the relation is to be verified. LCM into HCF is equals to 182 into 13. So 182 into 13 2366. 182 into 13. 13 to the 26, 2 carry, 104, 106, 6, 10 carry, 13 and 10, 23. Now product of given two numbers. Product of two numbers is equals to 26 into 91. 26 ones are 26, 2 carry, 26 into 9, 2, 3, 6. So this is same. So relation is verified. Therefore we can write LCM into HCF is equals to product of given two numbers. Verified. So this is how we can find out LCM HCF by prime factorization method, and the relation LCM into HCF is equals to product of given two numbers. It can be verified. Now the question number 2 is 510 and 92. Sub question 2, 510 and 92. Now prime factors divisible by 2, 2 to the 4, 2 5s and 2 5s. Now 5 unit place, 5 5s 25, 3 17 3s 51 and 17 1s 17. So 510 is equals to 2 into 3 into 5 into 17, and 92, 2 4s 8, 2 6s, 2 2s 4, 2 3s and 23 1s. So 92 can be written as 2 square of 2 into 23. So first LCM, whatever the factors, take every factor once. 2 into 3 into 5 into 17 into 23. But the power should be highest power. LCM is product of all the factors with highest power. So power 2. So we have to write 2. So 2 to the 4, 5 3 is 15 into 17 into 23. Whatever is the answer, that is your LCM. Now HCF, all common factors. What are the common factors? Only 2 is the common factor. So 2 is the HCF with least power. 2 raised to 2 is the highest power, 2 raised to 1. So with least power, so HCF is 2 and LCM whatever is the product. Now you can verify the relation LCM into HCF is equals to product of two given numbers. So you can verify this. We will see question number 3 in next period. Till then, bye bye. Thank you.